What is up, guys? This is Physics 2211 Lab 3, Black Hole. Here's the table of contents where we're going to be doing a computational analysis of a black hole, and we're going to calculate the motion of a spaceship around the black hole. Starting it off with some key concepts: Newton's second law of motion, which states force is equal to the rate of change of momentum, and for a constant mass, force equals mass times acceleration. We're going to be using this formula and variants of it to calculate the net force of, for example, a planet on a black hole, planet on a ship, things like that. And we're also going to be using the velocity and position update formulas to update each component's position. Gravitational force and force components. We have the gravitational force formula, which we will be using in our calculations, and each of the parallel and perpendicular components of the force, which will be important moving forward. So in part one, we're going to be finding the mass of the black hole. And if we take a look at our code right here, we have G, the gravitational constant, the mass of the star, delta T, which is the amount of seconds in a day. And for our calculation, we're going to we have P initial, mass times velocity, and final, mass times V final. Delta V, delta P, dP dt is delta P over delta T. And then we have net force, dP dt. And then we're going into each smaller component. We have the parallel component of force and perpendicular component of force right here, and we're going to be graphing these around the motion around the black hole. And at each iteration, we have a calculated mass of the black hole, and these are going to be different on each iteration just because of rounding errors. We're using V final as, or V initial as the V final of the last iteration, so there's going to be a little bit of change. So I'm going to be doing the average of all of these values, which I'm just going to be doing by adding up the total mass and then dividing that by the amount of iterations. And then we get the motion of the planet around the black hole with the changing force components. And then finally we get 1.26 times 10 to the 34th as the average mass of the black hole. And in part two, we're going to be preventing a spaceship from crashing into it. So using this average mass value, we're going to be plugging it in right here. And then we have other constants: G, the mass of the planet, mass of a spaceship. And then in our calculation loop, we're going to have, I calculated the force of the black hole on the planet, and then the force of the ship on the planet. That's how we get the net force on the planet. And same thing on the net force of the ship. We're taking into account force of black hole on the ship and force of the planet on the ship. And then right here at each iteration, we're going to be using the velocity and position update formulas to actually update each component's motion. So we take that into account. Then if we run this, we see that it will just miss it. And these are initial velocities of negative 4.8 e to the 7 and 2.5 e6. And some possible sources of error could be rounding errors after each iteration, which I just explained, and possibly the simplification of the gravitational constant. And what does it mean? Net force and its parallel and perpendicular components versus the rate of change of momentum and its parallel and perpendicular components. So the net force is equivalent to the rate of change in momentum. We know that based off of Newton's second law. And the components of the net force are equivalent to the rate of change in momentum. We can see this by if we split the net force down into its perpendicular and parallel components, that equals the net force, which is equal to the change in momentum. And what initial velocity would your spaceship need to have in order to enter some kind of orbit around the black hole? We would need a trajectory that has a higher vertical component than in part 2, because in part 2 it had a high enough escape velocity to just go swing out of orbit. So if we switch these values that I calculated before, let me comment this out and then comment this out. And let me make it run a little bit faster just to save time. And then we have a little orbit. Oh. Let me increase the time, because those calculations are only over a day. So if we increase that, we'll see that it'll eventually reach an orbit around the black hole. There we go. Alright. Thank you guys for watching.